Hello, good evening everyone. This is Madan. I'll be taking through a quick introduction of Apache Solr course, what Edureka would be shortly introducing. So welcome everyone, and this webinar will be roughly around for an hour, and we'll be covering some of the basics of Apache Lucene and Solr, and we'll be discussing about the course. So at any point of time, if you have any questions or queries, please type in your questions or queries into the questions window. At the end of the course, at the end of the session, I'll be just spending some time in answering a few of them. So let's get started. Can you just quickly confirm if you could all hear my voice loud and clear? Any one of you? Great. Thank you. Fine. So before getting into the details of this session, so I'd be just briefly walking you through what this course is all about. So we are starting Apache Solr course for 8 weeks, or for the 4 weeks, 8 sessions or 8 classes on the weekends. So this will be a live online course which would be led by an instructor, and all your courses can be accessed for lifetime using our LMS portal, and we have 24/7 class support where you can reach out to the Edureka staff for any queries even after the classes. And also we will have a lot of interactive sessions and interactive quiz kind of interactions happening in the classes. Followed by we'll have a real-time project where you can work on the technologies and the concepts what we have taught in the course. And also at the end you will be going for a certification by providing your knowledge and skills gained in the course. So that's roughly the outline of how this Edureka courses usually work. So I'll not further get into the details of it. You can always reach out to the Edureka support staff to know further details on this. Great. So what we'll be covering in the next 1 hour session is basically understand the need to have a search engine. What are search engines? Where and all it can be used? What kind of problem it solves? And what are the challenges of building a search engine? And what are the 2 key aspects like indexing and searching, how it is done, what are the nitty-gritties of indexing a contact, and the details of it. Since Apache Solr is built on a framework called Lucene, so we'll be briefly discussing about Lucene and the things, how it's done in Lucene, and eventually we'll be getting into the Solr details and what it is all about. So we'll be touching very in detail in the course. This will be a rough walkthrough or the glimpse of what you're going to get in the actual course. Okay. Fine. So this kind of a site, like an e-commerce site where usually people go and shop for their products or articles or items, should be very familiar to most of you, right? So I'll be just briefly walking you through what this is all about. So most of the e-commerce sites, if you notice, they would be providing you something called a search text box or a search place where you can type in your query, what you're looking for, and then you can hit the search button and it would come back with all the search results, right? So this is more of a text-based search where the database has to be searched and bring back all the results and display it on the page. And also if you notice on your left-hand side, you'll also notice a lot of sections where you can filter the search results based on price or the brand what you're looking for, or some sort of attribute what you're specifically hitting into it. So most of the time all these features fit into a search component or a search application. So initially when people started building search applications or the application which would need search feature, so they started with the databases prior to anything called Lucene or Solr. So with databases, if you guys are all familiar with how you can do a text-based search, right? So you have to do a select star from a particular table using the like statement and put the phrase or the term what you're looking into that query, and you search it back. So eventually what happens in the backend is you has to go and scan the entire table and look for the term or the phrase. Say for example, if you're looking for a quad-core mobile, it has to be exactly searched into the table by scanning each and every record. So when it was only say 100 to 300 thousands of records, it was easy to scan the entire table and fetch the results back and display it on the page or on the screen. So when the products or the records kept growing like into say millions of records, scanning the tables was a very slow process, and it is a very highly expensive operation. So people started to think something alternative to how to get out of this kind of a problem. Then they started using indexes. So what index does is, instead of going and scanning the entire table, you can go and pre-process the table to be optimized for searching. So that is what usually we call it as a indexing. So if you guys wanted to correlate something which is really near real time to an index kind of terminology, you would have seen something like an index on the back of the book, right? So the index of the book is something similar. What usually people prefer to pre-process the content and keep all the terms ready where they can go ahead and search it. So then people started building indexes on the databases, and it added some performance gains, and they still had to deal with the huge data when it is being added, or when you have to keep on re-indexing. Still the databases were not the efficient ones. So then there has to be something different data structure itself where the indexes are efficiently handled, because in the tables the index, the way how the B trees most of the time handles, is not very efficient for text-based search. So people started thinking to build something different, and that's when the Lucene evolved. So if you guys are not able to follow anything, please stop by or put your queries. I'll just try to be a bit more elaborate. If you guys are following it, just put some sort of smiley or some sort of yes kind of a thing, so that I could just get to know that we are all on the same page. Okay, great. So that was the starting point or the trigger. Why do we need a different search systems or a different search platform to build this kind of applications, or to build this kind of features which would serve the search needs? Fine. So as I said, before divulging into the details of Solr, so we would be touch basing what Lucene is all about, why we have to really bother about Lucene, and what it really offers us to explore. Fine. So Lucene is a Java library which is built for building indexes which is easily searchable and easily indexable. So which is in pretty simple terms is a very simple Java library used to index data and search data, because in any search application, by this time you would have figured out there are two key aspects which is very critical: the way how the data has to be stored, what we call it as the indexed data. The process itself is called as indexing, and the other secondary part to it is the way how we query that index data. So these are the two powerful features which any search platform or a system has to offer. So Lucene offers a very powerful features of indexing the content to easily search on the documents or on the records and easily retrieve those documents. So you guys have heard about the famous guy, the duck cutting, who is the creator of much more powerful frameworks other than Lucene. So even Lucene is being created by duck cutting. So it's very powerful. It's an open source. Yep. Hadoop has also been invented or created by duck cutting. So it's a very powerful Java search library, 100% open source and purely written in Java. And Solr is built on top of Lucene. That's the reason why we are trying to understand what Lucene is, and in details we'll be getting into the Lucene much more elaborately in the course, but we are touch basing the basics of it here. Fine. So as I mentioned, there are two key aspects to build any search application. So indexing and the searching process. So the basic reason why we need indexing is to make sure the efficiency of the data which is stored is easily retrievable in a most efficient and the fastest way. And without indexing, you'd be ending up doing something like a full table scans, and you will be ending up consuming more resources to go and retrieve those documents. So that's a primary reason of indexing the content in a way that it can be optimized for speed and performance for easy retrieval. So by indexing, you can go ahead and do a small lookup kind of a thing into some sort of a map where you can locate those documents, similar technique to the way how the books are indexed and stored all the phrases or the terms at the back of the page. So this is the same technique which will be very efficient in the search applications or search frameworks. So just to give a very high level flow of what really happens in indexing when you are using a framework like a Lucene. So a document in Lucene terminology or in Solr terminology is nothing but a record. So a record initially will be submitted to the indexing process, or a bunch of records or documents. So before it gets stored into the index, it has to be analyzed the way how the documents has been submitted, whether it is an XML document, whether it is a pure text document, whether it has a lot of garbage text or garbage characters. So all those analysis has to happen upfront, because the entire document cannot be stored as is for indexing, and it has to be analyzed first and do some sort of a preliminary investigation before it can be submitted to the index. So the first step always is the analysis process. And once the analysis is done, so the document itself again cannot be stored as is even after the preliminary analysis and doing some sort of pre-processing. So the documents has to be converted into tokens or terms. So a document can have, say for example, I can treat this as, let me take an example. I can say a document could be having a lot of text. Hello Edureka, something like this, Apache Solr. Right? So if you wanted to store this document for indexing, you have to break the entire document text into tokens or streams. A token is nothing but a independent or a atomic unit of text or a stream of text, which we call it as tokens or streams. So once the document is analyzed and converted into tokens or streams, it is then submitted to the indexing process, and the document itself is most of the time stored in the inverted index data structure model, which we'll be covering it very soon. So far we will just tag it as these are the two key steps or the key process steps which happens into the indexing flow. So on the bottom side, you may notice this is exactly what happens. So once the document or text is analyzed, it is sent into the tokenization. The tokenization splits the stream of text into each word or terms. Most of the times people use it alternatively, term, token, word, or whatever it is. Most popularly used is token or term. So once the tokenization is done, so the way how the index stores those terms is something called as a term vector or bit vectors most of the time. So here on the text stream, which we call it as one document, I have two terms or two tokens. Each term or token will be stored as a term vector by remembering its position, offset, and length. So every term vector will represent every token or a term. And when you are searching for Edureka, so the first lookup happens into this term vector to locate the term or the document where it can be found in the index. So this is at very high level how the indexing data structure is represented in Lucene. Okay, so when I said you can have multiple documents or a document which can be submitted to the index. So most of the time you can correlate a document nothing more than a record or a set of fields. So a document can contain set of fields similar to your database terminology. If you wanted to correlate, a record can have multiple columns. In documents also you can have multiple fields. So a document with a composition of fields is represented as a document which can be submitted to a analysis process. Most of the time the analysis process is handled by an analyzer, which we will be covering it more or less in a very high level today. So the analyzers analyze the documents and the fields, what kind of fields they are, what kind of document it is, and based on what kind of analyzer you are using, it will do some sort of pre-processing. Once the pre-processing is done, the document and the fields will be submitted from the analyzer to the index writer. So the index writer takes care of updating the index. So this is just the high level process of creating an index. So similarly, as I mentioned, there are two aspects in building any search platform. It's very critical for us to understand the indexing part and the searching part of it. So once you have indexed the data into an inverted index or the index storage, so you have multiple ways of retrieving that information back. Either you can use straight away Lucene APIs. So you can use a lot of Lucene API flavors, which we'll be covering in very short. So you can use those APIs to retrieve that information, or you can use something called a query parser, which is something similar to your ANSI SQL or a SQL syntax. So using a Lucene query parser syntax, you can do something like a select star from this index to retrieve all the information what you want. So that's what we call it as the expression language of Lucene. So Lucene also has its own expression language where you can write expressions to query the information what you are stored in the directory or stored in the index. Yeah, so directory is nothing but the index, what we are calling it here, as simple as that. Okay. So here in the searching components you will come across, so the first thing is if you're doing a query parser kind of fetching or the query parser route, you have to build an expression and then submit it to a query parser. So along with the query parser, there has to be some sort of an analyzer which will be working in conjunction with the query parser to analyze what you're trying to query, whether that query fits into the index what we have stored it and the analyzer what we have used it in the indexing process. Once the query parser is through scanning the syntax of the expression, it submits the query object to the index searcher, which retrieves the results or the documents and gives it back. Fine. So since we have seen the indexing process, as I've said, Lucene uses the inverted indexing technique to store the documents into the index storage. So let's briefly understand what is this all about and why we have to worry about looking into this. So inverted indexing technique is nothing but when you see a table index where when you index something and you are looking up into an index and retrieving the information, the straightaway indexing is not very efficient. So you have to have some sort of a pre-lookup for the index as well. So we are adding one more step, the pre-lookup for the index itself, and then we go and fetch into the index. So rather than directly going and looking up into the index, we also have something called term vectors, which acts like a pre-lookup map into the index. So that's one advantage of having inverted index. And the second aspect is there are a lot of things where indexing process itself will be very time consuming and slow when you have bulk updates happening into your index. Say for example, if you are updating your documents very often, even if you have a moderate size of your indexing database, index storage, updating more frequently is also going to cause a lot of challenges. So Lucene uses something called a merge sort to update the bulk updates. So basically what Lucene does is it accumulates the updates between some duration and then creates a new local block and then merges with the entire index. So this technique of merging the index proves to be really efficient than any other models of using a B tree indexes or some other techniques where you have to keep on altering your B trees rather than merging it with some bulk stagnation provides a better performance. So if you notice, so on the right hand side you may see there are new records or documents which is being added, and this documents gets accumulated and eventually it gets merged into the index. So this is a very brief approach of Lucene, how it handles the inverted indexing. So we'll cover these topics in details when we get into the course, so I just wanted to touch base some of these things. Fine, so as I mentioned, Lucene, like databases, it does not have anything called a schema or a relational structure kind of a thing. So Lucene storage schema is very flexible. So for example, in one document you can have 2 fields, in another document you can have 3 fields. That's the first level of flexibility. And the other level of flexibility is the third document can have entirely different set of fields. So it is not mandatory that every document has to have the same field. So it is up to the record how they wanted to consume those fields in the record. So it is very flexible. So you can have any number of fields and you can have any field in the document. So there is no mandatory or constraint that you have to use this kind of field or this kind of things. So in the storage schema you can have multiple documents. Each document can have multiple fields. Each document can have variable number of fields and different fields altogether, and each field can be of different types. There are different types of fields what Lucene supports, like based on the field types. It could be a copy field, it could be a text field. So we'll be covering all those things in detail later point of time. Okay. And also one more point, it's not that your schema or your structure is always fixed, so you can add more number of fields dynamically based on your requirement of your application. So you don't have to worry about that. Once I fixed the schema, you have to stick to it, right? So as we have seen, the most important step or the most important aspect in creating an index or searching is the analyzers. So what analyzers does is, once the stream of text or the document is submitted to an analyzer, so the analyzer reads the documents or the text, which is most of the time the first step of interacting with the analyzer is interacting through a reader. So reader is nothing but a IO object in Java. So that's the reason one of the prerequisites for this course is Java. So even if someone is not from Java background, so we will be offering a complimentary Java course which we would recommend for people to go ahead and take that course so that they can understand and follow what the kind of terminologies the course will be using it over the period of time. So the first step of interaction with the analysis process is interacting with the reader, where you submit the text stream or documents to a reader. So the reader takes all the documents and it creates a token. The tokenization process is handled by a tokenizer. So there are different tokenizers, different readers, which we will be coming across when we explore the APIs. So once the tokenizer creates the different tokens or splitting process is done, you can use n number of token filters. So there is no limit. So you can use one token filter, say for example, to stop all the bad words in your text stream. So if you wanted to stop any abusive language in your documents, you can go ahead and use a token filter which can do that job for you. Or you can say, for example, you wanted to convert all the text in your document to lower cases, you can use something called a lower token case filter. So there are a lot of token filters which you can use it. So these are all the classes which you will be using it to build an analyzer to create an index. Okay, eventually the output of it will be tokens which will be created as a term vectors into the index. So the input or the interface is through the reader. Okay. So just to give a brief high-level idea of what analyzers you can be used or you can expect in the course. We will be covering some of the analyzers, like say for example I have spoken about the stop analyzer or the porter stem filter. So the stop analyzer, it stops all the bad words before creating the tokens or term vectors into the index. So there are a lot of analyzers. Say for example, Lucene is not a platform or a framework which only works with one language. So it has to work with all multi-language or international capabilities where you need multi-language capabilities. So you can use any language. I've just provided a snippet of it. This is not the extensive list. So the complete list will be covering it by showing a screen of the analyzers classes, what it supports. So just to give a fair amount of idea what you can expect in analyzers, what you can expect in filters, what I have shown it in the previous step. So lowercase filter, as I mentioned, it converts all of the text into lower cases. So those are some of the things what you can see in the analysis step. Okay, so since we have seen the analysis step, so we can also have to go through some of the things like what are the different types of querying techniques is available in Lucene. Eventually you can do a lot of querying. So I've just provided using APIs. So you can do a fuzzy query, you can do a reg expression query, you can do a prefix query. So these are all the things what we'll be covering it in the course in detail. So just to give example, so let's pick up a prefix query API. So the prefix query API will be used to prefix any word or a token of a stream of characters to search for a document, so that you can prefix some characters to look into the documents and fetch those documents. So there are a lot of APIs which you can use it for querying as well. So just to give extensive list of things, we'll be covering some of these things in detail. Fine. So there is something called scoring, which is a very interesting topic. I thought of just covering it. So scoring is nothing but, say for example, you are retrieving the results or the records from the storage. So if you have to sort them and give some preference to some records, say for example, if you're running some promo or some advertisement on some particular product or an item, so you can boost based on those matches and give some importance to those documents to come up in the order. So that is nothing but the score boosting or the boosting, what we call it most of the time. So the boosting or the scoring can be done at two places. One is while you are indexing, you can create a permanent index for a document and then store that document for that particular term when you are indexing it. So when you are boosting it, you have to boost the documents of the fields of the document so that you can go and retrieve those records with that preference when you are querying it back. Say for example, if you don't want to boost those documents by boosting some fields, you can also query those records and boost those records into upper segment by doing a query time boosting. So these are the two popular ways of boosting the records to some degree so that you can fetch some termed documents in a better place. Fine, so we will be talking about all of these things in detail. I'll just give some brief about what these features Lucene supports. So faceting, highlighting, grouping, joins, spatial search, and ticker support. So faceting is nothing but, you might have seen the left side corner of your e-commerce application when Lakshmi has a query, where are we going to store all these indexes? That's a great question, Lakshmi. Thank you. So these indexes are eventually stored into a flat file of the Lucene or Solr, eventually wherever you are providing the path to store it. So that acts as a database. Okay. So we can explore that a little bit more. So faceting is nothing but, you can retrieve the records or results based on some sort of facet value or based on some sort of grouping with counts. So let me just go back to that initial screen, what I have shown on the first page, so that I can just show you what exactly faceting means. So if you notice here, you might have seen a lot of records on the left hand side grouped based on pricing. So we can see there is a price range between 2001 to 5,000 bucks with 6 items. So similarly, there are a lot of items based on different groups. Okay, so this is some feature which is very oftenly used and which will be a key feature if someone wants to just only pick those records. It can be easily queried using the feature called faceting. This is what we call it as faceting. Okay, so this is something different from grouping, where a grouping just groups the related documents based on how you want it to group. A facet is basically you group and also count on terms related to some aspect like price, brand, operating system, or whatever it is. Okay. So highlighting also, you might have seen, say for example, when you're searching for a term in a search application, if you are returned with some results, you might see the terms what you have searched for would be highlighted in the description of the product or in the document descriptions. So most of the time this feature will be helpful, that this is the particular term which has been matched to retrieve your records. So that is what called as highlighting. So similarly, grouping, as I mentioned, if you wanted to group related records or documents into some category or into some sort of grouping, we'll be using the grouping feature of Lucene. So joins is something like you wanted to join, say, 2 different set of documents based on some field or based on some aspect or attribute, you can use joins. So spatial search is something like, say for example, if you are trying to locate documents based on geolocations or based on some map kind of an interface. Say for example, if you're building an application, hotel application, and you're trying to find nearby hotels from the airport. So you may have attributes like latitude and longitude located as fields in the documents, and those documents were indexed. Then you have to go ahead and do geospatial algorithms to map or to find the radius between all those documents, which will be a huge mundane process and algorithm which you have to cover. So instead of that, Lucene provides all these kind of features of spatial search, which is already supported. So similarly, Tika is Apache Tika is something like where you wanted to index rich content like PDFs, Word documents, and other documents like Excel, all the documents which has a lot of metadata and binary content which has to be stripped, and only useful information has to be extracted. So these kind of features can be used in conjunction with Apache Tika. So that's just a brief nutshell about what Lucene is all about. So in the course we will be covering Lucene for 2 modules with a lot of practicals of using the APIs of analyzers and all the query APIs and different scenarios of using each one of them. Fine. So let's quickly jump on to the Solr aspect of it. So since our course is covered for 8 modules, 6 modules will be extensively on Solr and 2 modules will be on Lucene. So most of the concepts or terminologies are derived from Lucene. So Lucene is a very strong foundation for us to explore all these details. So Solr is nothing but an open source web application built on top of Lucene API libraries, as simple as that. So whatever the features Lucene offers, Solr provides the same set of features. On top of it, it provides a lot of other tools and extends and overrides some of its features as well. Okay, that's the second benefit of Solr instead of using direct Lucene. So the third benefit is sometimes using the core Java APIs will be really challenging because you have to have that Java expertise, and fine-tuning the Java for performance and all that stuff would be really challenging. You can use the RESTful APIs what Solr provides and use them as a service instead of directly interacting through APIs with the index, which adds a lot of interoperability with different frameworks or platforms. So you can interact using RESTful services either over XML or JSON or CSV or binary format or HTTP. So this is the most preferred interaction between the indexed content and the applications, so that you don't have to build or write Java code using Lucene API libraries. Fine, so just a quick intro about when Solr got introduced sometime in 2004 by Yonik in CNET Networks. So I'm not going to get into the details of it. So when initially Solr was invented and used, it was mostly used as a master-slave architecture, and it was used for limited data sets. So Solr was initially not capable of scaling to huge big data sets. So the new versions of Scalar has been re-architected and redesigned to handle huge big data sets so that you can scale it for any imaginably bigger data sets what you can think of, even in petabytes. That's the biggest enhancements what you could see after 3.0 releases. So apart from that, we will be covering SolrCloud, which will be adding a lot of performance and scalability and reliability aspects. In the initial versions or stages, the Solr used to have master-slave architecture where you have to use master for all writes, and then you have to use slaves for all reads. So this kind of architecture provided a lot of challenges, and you have to use all your updates or writes in a stagnated approach. So there was no real-time or near real-time read and write kind of a concepts initially with Solr. So those are the earlier versions of Solr. So the new versions with 4.0, which we'll be covering in the course, which is a much more enhanced and superior platform which can offer you all those kind of features. Great. So we'll be seeing just a quick walkthrough of what we have seen Solr so far. So Solr offers you advanced full text search kind of a capability to your applications. So it is web scale platform. You can scale to your web needs dynamically. It can scale elastically with the newer versions. It operates or provides interfaces over HTTP and XML or JSON as a RESTful service, so automatically it provides a lot of interoperability. And also you have got a lot of administrative or configuration management or managing your Solr servers has been done through your administrative web application, which can be handled easily rather than going and working with the configuration files. So there is a lot of monitoring and scalability aspects which has been enhanced or which has been provided as part of the Solr. So Solr gives you the option of building applications, search applications with ease. So you don't have to worry about the scale problem, you don't have to worry about the minute details of the API, changing the API, all that stuff. So you install a Solr server on a Java compatible web container like Tomcat or Jetty or any other web container. Your search engine is ready to go and start working on it. Okay, fine. So we'll not be covering a lot of details into the architecture, just to give the idea about what the Solr architecture has got. So on the top of the image you could see the request handlers. So the request handlers is nothing but the incoming request over HTTP or RESTful services is intercepted by a request handler. So there will be a lot of request handlers by default which is configured, and also you can plug in a lot of request handlers to intercept your incoming request. So admin is a request handler which will handle all the administrative tasks. So select / select is a request handler, or in simple terms you can think of like a servlet, which is a servlet which intercept different URL contexts. Okay, so spell is a request handler which will handle the spell checking part, kind of a thing. So there are different request handlers. We have provided a glimpse of it so that you can understand what is a request handler. So your input query to retrieve the index can go to any one of the request handler to perform your application needs. Okay, so once the request handler intercept the incoming request, so there will be a lot of search components which can be configured and used by the request handlers. So you can see there will be search components like highlighting. If you wanted to use a highlight feature, if you wanted to use the face setting feature, you can use some of these components, and these components will be handling those core features or the key features. So once the component handles the incoming request, it goes directly into the distributed search where it fetches the records and gives it back. On parallel, you could see there are a lot of config things and also a schema management, and you can also see request writers. So request writers is nothing but it is completely different from request handlers. So request handlers are for reading the documents, request writers are to update the index. So there are different forms of request handlers. So you can use a XML request handler to submit XML content. You can use JSON request writer to process the JSON format of your document, or you can use a database import handler to import the data directly from the database tables and write it to the index. So those are the responsibility of the request writers, or you can even call it as update handlers sometimes. Okay, so request writers and the update handlers, they both together handle all the indexing process. Okay, so some of these things you can also see on your right hand side. There will be a query parser, and all the components can interact through a query parser. So we'll be looking all these things in detail when we get into the course. So some of these things I've just briefly explained. So I just wanted to quickly show you the demo of the admin UI. So the admin UI provides you the complete management of your Solr server, which can be used to configure your configuration files, configure your admin cores, and configure and manage your indexes itself. Indexes is nothing but a database in correlation with the databases terminology. Fine. In a nutshell, if you wanted to just visualize how would your Solr be looking like, so there can be multiple Solr instances running. When I say multiple Solr instances, so you can deploy the web application on multiple servers so that each server runs one instance of it. Okay, so that is what we call it as a Solr instance. So every server or instance can have multiple databases or indexes or cores. I'm interchangeably using databases so that people, those who are coming from databases background, they can feel it comfortable. So otherwise we don't refer them as a database. Most of the time we refer it as core or one index. So one server can have multiple cores or multiple indexes, right? So this could be like a HR department index, this could be like a finance department index, and the third one could be something like a IT department index for different applications or for same application as well. Just to create that different categorization, you can also run different indexes or cores on different Solr instances or on the same instance as well. So each core or index can have documents, and each document can have multiple fields, right? So every core or index will have a schema.xml file which will define the structure of the core. Okay, so which is very flexible. You have to define what kind of fields, what kind of field types you're going to use in that index, so that when you are indexing the documents, it will follow that particular structure. Okay, so as I mentioned, a Solr can have multiple cores, or a Solr server can handle multiple cores. So a core is nothing but an index which is handled by the Solr server. Okay, so if you wanted to run a Solr core, you have to have few XML files which you use it for configuring and controlling your Solr instances. So there are only 3 to 4 configuration files which you should be aware of. One is the solr.xml, which will be the configuration file for your entire Solr, and solrconfig and schema.xml. So schema.xml, we have seen, it is to define the structure of the core, right? And solrconfig is to define the architecture of your core or architecture of your instance. Say for example, if I am using a XML request handler, I will define all of those components into solrconfig. If I'm defining what kind of update handler, so all of those things will be handled in those configuration files, which will be covering it in detail in the course. Okay, so again, when I said a Solr server can have multiple cores or databases, so it is not that each core cannot communicate, but most of the time they run in isolation as isolated databases. Okay, so it is not intended for interacting between multiple cores and that kind of features. Rather, okay, so Lakshmi Narayana has a question. Google, Yahoo, Bing also uses index based on search engines. Yes, absolutely. So most of them, more or less, the approach remains the same. So Yahoo is one of the biggest consumers of Lucene and Solr, where it's not for the they use a different platform and techniques, but most of the applications like Yahoo Autos or Yahoo Finance, they all use Solr or Lucene in the backend to index the documents and search those documents. So if you are referring to the Google, Yahoo, Bing search engine, it's much more complicated technique or platform. They might not be using something like Lucene or Solr. So Lucene or Solr is used to build applications around search. Okay, so they are two different things, in fact. Fine, so if you just wanted to get a glimpse of how the documents would look like in Solr, as I mentioned, you can use different request handlers. Say for example, if you are using XML request handler to index your content, so this is how something you can envision or the documents would look like. Since you said you wanted to use a XML request handler, so you have to follow the XML request handler syntax, which will be like doc. Inside that you can have field name and the value of it. Most of the time it will be like a name value pairs. So if you notice, this will be like a document and list of fields. In the field it is a name and value, okay. So we have seen that Solr can support multiple request handlers. This is just a quick recap of what type of data you can send it to Solr for indexing and searching. So you can send it any type of document, mostly used documents like CSV files, Microsoft Words, PDF, provided that you have configured all those request handlers and search components properly. You can almost use all the metadata type documents or plain text or XML or JSON to index the data into it. Okay, so Solr uses something called Solr Cell Framework, in turn which uses the Apache Edureka, just the way how Lucene supports rich text document analyzing and indexing, you can use Solr to handle all that rich document types as well. Okay, so for interacting with Solr, apart from RESTful web services, there are a lot of Solr clients which can used to interact with the RESTful services rather than you building your own APIs to even interact with the web services. You can use the SolrJ clients or Solr Java clients, or there are a lot of other language clients which can be used to interact with the Solr instances as well. Okay, Srini is keen to understand what is the key differences between Solr and Lucene in simple terms. So Lucene is nothing but a set of API libraries which can be used to create indexes and search indexes to get read and write documents. Okay, so if you are building an application, you have to use those libraries and build applications. Solr is nothing but a web application built using those same Lucene libraries, so that you don't have to write code to interact with the index. You can use the web APIs or RESTful services to interact with Solr. In simple terms, that's the difference. Got it, Srini? Okay. So since we have seen the Lucene flow of creating indexes and analyzers, so this should be a straightforward self-explanatory thing. So the analysis part, again, it can have analyzers and tokenizers and list of filters. So all these things can be configured in your configuration file, solrconfig file, which can be defined using the XML file, and your Solr config file looks something like this. So there are a lot of configuration aspects which we'll be talking in detail when we go to this place, so that you can get what kind of details you can configure it. Okay, just for an example, I have said you can create an update handler, and you can specify what kind of query or the search component you're using. So you can specify all those things here. Okay, so just a quick overview and recap of the Solr search process. When you send a request, it goes to a request handler. So the request handler can be of any type, like select or admin or spell check, based on what you have configured. The request handler sends it to the query parser. So Solr also has its own search expression language extended from Lucene. Using that, you can write expressions to query the documents. So that is handled by the query parser, and the query parser analyzes your syntax. If the syntax, everything is correct, or it follows as per the syntax, then it goes and fetches the document from the index and returns it back. So that's the high level flow or the process which you can come across in Solr. So apart from what we have seen in Lucene, Lucene is the API library which Solr uses. Solr also extends the same features like Lucene. It also provides faceting, highlighting, spell check, query re-ranking, and more features which we would have not come across in Lucene. So more like this, right? So if you are looking for some results or some documents, Solr can recommend you documents more of this sort. You might have seen this thing in a lot of e-commerce applications. Do you want to see more of this records, right? So those kind of features can be supported by Solr. Apart from like auto suggestions, like say for example, if you are trying to type something and you are not very sure what exactly you are looking at, so there will be a drop down which will be coming the moment you type. Say I need say Android phone, so it will type and say, are you looking for Android KitKat phones or something like that. So it will provide a lot of suggestions as well, and also it provides a lot of real-time update and read features, which is very hard to achieve it in the Lucene. So some of these features which we'll be covering in details. Okay. So the configuration files which we'll be covering in detail will be based on the course module. So we'll be covering Solr config, which will be handling the configurations for all the indexing and search components. Solr.xml is at the entire Solr level for the course, how many cores you have, what are the core names, all that details. The core properties is for the defining some properties at the core level, and schema is at the core data structure level where you can define what field type, what field it is, all that aspects. Fine, so let's briefly touch base on SolrCloud since we are just running short of time. So I'll be quickly covering this part and then we can go into the Q&A if you have anything. So as I mentioned, Solr initially used to have master-slave architecture prior to 3.0, which got changed into a distributed architecture which provides a very robust and fault-tolerant platform to support high availability using a feature called SolrCloud. So we'll be covering all these things in detail. And SolrCloud is not a master-slave architecture. It does not have a dedicated or a blocked master. Rather, it will select leaders based on the request dynamically. So some of the features what you can get using SolrCloud with the new versions. SolrCloud is not a feature or a terminology which you can represent that Solr can be used in cloud. So it's not. It is a feature which is being termed as SolrCloud. So Solr, yes, definitely it can be run in cloud, but it does not represent that it is running in cloud. So it is for a different architecture what we run it, what we name it as SolrCloud. So SolrCloud architecture can be used for big data needs, for horizontal web scaling where you have high availability and fault tolerance, where the data is sharded and replicated in multiple shards, which provides high elastic scaling and distributed searching and indexing. So we'll see how all of these things happens when we get into that module in the course. So for now, it is a much more enhanced version compared to the prior ones. Okay, just to give a glimpse of it, initially the Solr used to be a master-slave architecture. The way how Solr can support distributed scale and web scale is through having multiple shards, and the data is duplicated or replicated into multiple shards, and each one of your read or write request is going through zookeepers, which will elect the leaders to suffice the read or write purpose. Okay, so that way you can have high availability with a lot of fault tolerance incorporated into the distributed search architecture. So SolrCloud is nothing but a distributed high available architecture which you can use it for real-time applications. Great. So this is again a very interesting slide. So you can see there is a lot of adaptions and a lot of job trend which just got picked up in the last 4 to 5 years. So this seems to be really interesting. So this is one of the should be one of the strong motivation factors why you should go and learn Solr, so that there is a lot of opportunity going around. So please look around and see if there is a lot of energies which is going on adapting Solr. So I think it's a great okay. So I just try to be on time. So we have got another minute or so that I could take few questions, couple of them. So Srini has one. So are these Lucene and Solr used only in the big data world? Great question. So I said it's not required that it has to be in a big data world. So Solr can be used for your small search capabilities, but it can handle the big data needs as well. Okay, so even if you have say 10 GB or 10 GB of data which needs to be searched and which needs to be retrieved, you can use Solr, or if you have 10 petabytes of data or documents, you can still use Solr in the SolrCloud architecture model. That's what we call it as. It can suffice the needs of big data as well. So Solr new versions is treated as a big data NoSQL database. Initially it was not supporting that kind of feature where it can handle a lot of records. Okay. Great. So Lakshmi Narayana says, is it suitable for Hadoop developers? Great question, Lakshmi. I would definitely say yes, because there are two different technologies which can work in the big data space. Say for example, if you are a developer trying to build search applications, so it would be definitely useful. So please use your own discretion. I would definitely say yes, as long as you have a lot of aspiration to build applications using these key technologies which are being used across. So I would recommend you guys to go for it. Again, it's my personal opinion, so use your own discretion. So Srini says Java is a must to be a Solr developer. No, Lucene, for us to understand Java basics are required. For Solr, you don't have to be a Java developer. That's the reason Solr is built using the Lucene APIs, and it provides web services interface or RESTful APIs like XML and JSON. So you can use any SolrJ client or Solr client from say PHP or say from .NET or say from Ruby. So you can use any language which you are comfortable with and interact with Solr. So this is purely like a database. It doesn't have any dependency on the language. Great. So I would just go for one more last question if you guys have it. If we don't, I'll just call it off, and I'll just wait for a few more seconds before it can be called off. Great. So thank you guys. Thanks for your time, and thanks for attending on the weekend. I appreciate your time. And I got one more question. Where can we find more jobs? Okay, so I think this is a little bit more generic question for Apache Solr. Okay, that's somewhat relevant. So yes, I think so. I would try to see if it can be accessed or shared. Okay, so I think Apache Solr is being used in almost every decent application where it has to have a search feature. So it's not only restricted to say e-commerce applications or say any portals like e-commerce applications. So it is being widely used across enterprise applications like online applications, so social apps. So there is a lot of demand, and what my guess is every search feature which the companies use, they are using either directly Lucene or the Apache Solr or the Elasticsearch kind of a feature, again, which is built on top of Lucene. So there is a lot of opportunities for sure, which I cannot quantify it, but I could say from my experience, because I've seen, at least in my past 4 jobs, all the companies were using Apache Solr. So this is more of a de facto nowadays. Great, guys. So again, thanks for coming, and we'll see you soon in the classes if you guys are excited, and we'll take it further from there. Okay? Thank you.